Hello students, today we are going to discuss the Keto enol Tautomerism. It is very important part of isomerism. We know isomers are having same molecular formula but different structures. Just I will tell you one examples. Suppose you look at my figures. So this structure is one type of posture of my figure. If I am expanding my hands, this is also one type of structure. If I am closing my left hand, this is also one type of structures. But hands are also available, but position are different. So here what happens? So isomers can be formed by changing the structure in the molecule but keeping the formula remaining same. But in tautomerism what happens? The different types of structural isomers, they are remain in dynamic equilibrium with one another. This dynamic equilibrium between the structures and this one form can be interconverted to another form. This type of structure is called Keto enol Tautomerism. Here what happens? The two structures are remain in dynamic equilibrium but formula is same. So in Keto enol Tautomerism, what happens? The keto form, the keto group is converted to enol groups. For examples, if you have take the one examples that here CH3 C double bond OH, these structures exist in equilibrium with, suppose you bring this hydrogen to oxygen. Here what happens? CH2 double bond COH and H. Here this structure and this structure only differ in the position of hydrogen. Here hydrogen, it was in CH3 with CH3 with carbon. Now this hydrogen shifted to oxygen. That is displacement of hydrogen. Which hydrogen? Generally alpha hydrogen atoms. When alpha hydrogen atom shifted from one atom to another atom, resulting the tautomers, and the tautomers exist in dynamic equilibrium between the two structures. That's why it is called tautomers, and it is also called functional isomers, and they exist in dynamic equilibrium. Here that tautomers can be possible by shifting of hydrogen atom from one atom to another atom. It can be exist in dyad forms, can be exist in dyad or triad. Or triad. Here what happens? This is the first carbon, first atom, second atom and third atom. So hydrogen shifting from this first carbon to oxygen, that is third atom. So this is called triad. Similarly, it can be shifting from one atom to another. For examples, we can take the example. Suppose that hydrogen cyanide, these structures, it also exists in, suppose, in dynamic equilibrium with like this SCN, it is HNC, like this. Here what happens? Hydrogen shifted to nitrogen. Here hydrogen attached to carbon, here hydrogen attached to nitrogen. So it is 1-2 shift. It is called also 1-2 shift. 1-2 shift is called dyad, and 1-3 shift, 1, 2, 3, from first carbon to first atom to third atom, that is called triad. So this type of shifting of alpha hydrogen atom from one atom to another is called tautomers. And the tautomers, it is also called keto enol forms. Here what happens? This is your keto, this is enol. Enol means having double bond and OH group, and keto means having only keto groups. So this keto enol tautomerism, if you see, it exists. For example, if you take one example, CH3 C double bond O and CH2 C double bond O and CH3. This is one tautomerism. It is also one type of organic compounds, that we can say it is 2 1 2 3 4 5, that is 2 4 here pentane 2 4 dione. This is called pentane 1 2 3 5, pentane 2 4 dione. This structure exists in tautomers by shifting of this, suppose this hydrogen atoms and forming CH3 COH double bond CH, then C double bond O and CH3. This is a one enol form. This is also one enol, and this is also keto. So keto forms, this is your keto forms, this is your enol forms, and these keto enol forms, these keto forms and enol forms only differ in the position of hydrogen atoms. And here if you see the stability of keto form enol forms, very important is keto form is more stable than enol form, that is stability. If you see the stability of keto form and enol form, keto form is more stable than enol form in stability, but both are interconvertible. Here why keto form is more stable, thermodynamically is more stable, because in keto form what happens here, what type of bonds are exist in keto forms, that CC bonds exist, and C double bond O bond also exist, and CH bond also exist. So three types of bond exist in case of keto form: C double bond O, CC bond and CH bond. And in case of enol form, what type of bonds are available? C single bond O bond available, C double bond C bond also available, and CH bond available. There are three types of bond. Here particularly this position you see, here C single bond O and C double bond C and C single bond H, like this, and OH bond also exist, OH bond. But if you see the thermodynamical stability, that bond enthalpy you calculate, the bond energy of keto form is more than the enol form. Bond energy, bond enthalpy of keto form is more than enol form. That's why keto form is more stable than enol form regarding the stability. And if you see the stability of enol, the stability of enol stability depends upon the solvent used, depends upon the structure of enol. For example, this keto enol form, CH2 double bond COH and H. Now this enol form of this compound CH3 COH double bond CH, C double bond O and CH3. In this form, it is also enol form of one keto, it is also one enol form of another keto form, this keto form. But here this form, it has intramolecular hydrogen bonding. Intramolecular hydrogen bonding, we can write like this: intramolecular hydrogen bonding. Which is intramolecular hydrogen bonding? I hydrogen bonding. This intramolecular hydrogen bonding responsible the stability of enol form. This enol form is more stable compared to this. This is also one enol form and this is also one enol form, but this enol form is more stable. This is less stable. This form is more stable than this form because it has intramolecular hydrogen bonding. So if the enol form is stabilized by hydrogen bonding, is stabilized by resonance, is stabilized by hyperconjugation, then the percentage of enol will be more. The percentage of enol form will be more. So you have to see in which enol form the stability is more, for which effect. either intramolecular hydrogen bonding or resonance effect. So many effect is responsible to stabilize the enol form. But in between keto and enol form, particularly keto is more stable than enol, but the percentage of enol produced depends upon the stability of enol. Like this, if intermolecular hydrogen bonding is more, that's why stability is more. In another cases, stability also depends upon solvent, nature of solvent. What, in which solvent the enol is more stable? The enol will be more stable in nonpolar solvent. For example, that is hexane. In case of hexane, then benzene, then acetone, then if you see that alcohol, then water. So in case of water, the stability of enol is very less. Why? Because water, what happens, in case, suppose this is the enol form, enol form, what happens, this enol form exists in hydrogen bonding with water. Enol form, this if you take solvent as water, then water forms intermolecular hydrogen bonding with keto group, so that keto group cannot form hydrogen bonding, intramolecular hydrogen bonding OH group. So in presence of polar solvent like water, the intramolecular hydrogen bonding will be obstructed, the intramolecular hydrogen bonding will be prevented. That's why the stability of enol will be less, will be decreased. That's why the stability of enol is more in case of non-polar solvent like hexane, benzene, acetone, like this. But in case of polar solvent, the stability of enol is very less. So you have to remember these things. Then if you see the stability of enol in case of structure, different structures, in which structure the stability is more, let us discuss these things. First, which is very important is that if you see the stability, order of stability of enol. If you see the different stability of enol, the stability is like this: CH3CHO less than CH3COCH3 less than CH3CO CH2 COC2H5. Then it will be, if you use phenyl group here, CO CH2 CO C2H5 is less stable than CHO, then CH2 CH2 CHO. In this case also it is more stable. This one also stability increases. Then if you use this less than CH3CO CH2 CHO less than CH3CO CH2 CO CH3, stability order. Then if you use that methyl group in benzene, also stability increases. This one with CO CH2 CO CH2 CO CH3, which is less stable if you use two phenyl groups, that two phenyl group CO then CH2 then CO, this group is more stable. Then it is also again stability increases if you use one nitro group. If you use one nitro group, also stability increases. here what happens, stability, here is very important thing is, in which case stability is increasing. Here order of stability of enol form with CH3CHO, already we have drawn the structure. CH3CHO enol form is CH2COCHO, this is the enol form, but here it has no hydrogen bonding, that's why it is enol form of this keto form, that is CH3CHO, is less stable. Then CH3CO, again here stability increases because due to position of methyl group. Due to position of methyl group, it has also hyperconjugation. Due to hyperconjugation, the stability increases. If you draw the structure of CH3CO, CH3 enol form, that is CH2 double bond COH, then CH3. So here stability increases because here double bond contains one methyl group. As double bond contains one methyl group, the stability is more. Because substituted alkene is more stable, alkyl substituted alkene is more stable. That's why acetone, enol form of acetone is more stable than acetaldehyde. Similarly, here due to putting this group CO, C2H5 ester group, the stability of enol is also increases. In case of phenyl group, stability also increases due to hyperconjugation. For examples, if you take these examples, this example you take, that is your resonance structures. If you take this form COH group, then double bond CH, then if you put CO, then benzene. This structure here, this enol form is more stable because due to resonance. Here this can be converted to this, that is conjugation. That due to conjugation, pi bond conjugation, the stability of enol is increases. One is also it has double bond O. You can say it has R double bond O. Intramolecular hydrogen bonding also exists, and resonance also exists, so that the delocalization is more. As delocalization is more, then stability will be more. So if phenyl group is attached to keto group, stability will be more due to resonance because the pi bond is delocalized easily. If methyl group attached to keto groups, stability is more due to more substituted alkene is formed, which is more stable as per the Sedgwick effect. So if minus I effect is there, for this is the minus I effect. If minus I effect is added, then due to the minus I effect, what happens? The H can be easily, this H can be easily removed from the acidic character of hydrogen will be more. In case of minus I effect, the acidic character of hydrogen will be more. That's why the formation of enol will be faster. So these are very important criteria regarding the stability of what? The stability of enol in different structures. Again, I am telling, in case of aldehyde it has no stability, only this position, but in case of keto, what happens? The substituted alkene is more stable due to more substituted alkyl group due to hyperconjugation. If phenyl group is attached to keto group, the stability of enol form is increases due to resonance, due to delocalization of pi bond. If minus I effect is there, then the H can be easily removed from the carbon and can involve in the formation of pi bond. So stability will be increased. So these are some important criteria regarding the stability of enol form. So that I will discuss some questions. That we will discuss one question, that which is more stable. That will be a homework question for you. You will just put the answer in the comment box. In the next class, we will discuss the answer. The question is like this. Before discussing the question, why, I will tell you why benzaldehyde. This is the benzaldehyde. Why benzaldehyde do not give enol forms? Because it has no alpha hydrogen atom. As it has no alpha hydrogen atom, so it cannot show keto enol isomerism, tautomerism. Similarly, if you take that benzophenol, if you take benzophenol has no hyperconjugation. It has no tautomerism. No tautomers is possible because it has no what? Alpha hydrogen atom. As it has no alpha hydrogen atoms, it does not show tautomerism. Keto enol tautomerism. Benzaldehyde also does not show keto enol tautomerism. So the question that I will give you, the question is like this. This is one structures, that is malonic ester, we can say, first one. Second one is CH3, CO, CH2, CO, C2H5. Third one is CH3, CO, CH2, CO, CH3, acetoacetic ester, that is your acetone, like this, or 1, 2, 4, pentane 2,4 dione. Another structure is like this. Phenyl group is just attached. Phenyl group, CO, CH2, CO, CH3. We will compare. The question is, you will compare the order of stability of enol form. Which is more stable in increasing order of stability? Answer is, write the stability of enol in increasing order. Increasing order. You have to write the stability of enol form of this A, B, C, D in increasing order. You write the answer in the comment box. Next class we will discuss the answer regarding the stability of enol form of A, B, C, D. Then which is the order, what is the, but we have to remember one thing, the stability of enol form depends upon the whether intramolecular hydrogen bonding is exist or not, whether delocalization of pi bond is possible or not, minus I effect is there to increase the stability of enol form, or it is favor the loss of hydrogen from the groups. For examples, I will tell you these keto forms. This, when it is attached to two methyl groups, whether the stability of enol form increases or not, but here the stability decreases because two methyl groups attached to carbon, it deactivate the loss of hydrogen from carbon due to plus effect. Due to plus effect, it deactivate the loss of hydrogen. It has no, you can say it has no alpha hydrogen atom. So the formation of enol form is not favor. Or you can say if the plus effect is increases attached to the carbon, then loss of hydrogen will be slow. That's why this case the enol form possibility, the stability of enol form will be less. So many criteria you can take regarding the stability of enol form, and you complete this question and send the answer in the comment box. Okay, thank you.